So this question involves a bit of roots and knowing how to factorize and expand expressions. So we've been given this quartic, the highest power of x is an x to the 4, and we've been given two solutions to the equation f of x equals 0. So these are two of the roots. Now it's a quartic, so we expect it to have 4 roots, and we've got 2 of them, but we can easily deduce one of the others because a, b and c are real. So if the coefficients of x are real, that means the complex roots come as a conjugate pair. So one of the other roots is 3 subtract 2i. And what we've got to do is we've got to fully factorise such that we get real factors. Well, what do we know so far? We know that f of x must have an x minus 4, as 4 is a root. And we could write 2 of the other brackets using the complex roots. Okay, but they're not, it wanted it as real factors, not complex factors, so we're going to have to do something with that in a minute. We can also then have a look. The x to the 4 term has a coefficient of 3, and so far, if I expand my brackets, I'm going to have x times x times x, which will give me x cubed. Now, if I want x to the 4, I need another x, but I need 3x to the 4, so this is going to be a 3x in the last bracket, and it's also going to be plus or minus number, whichever way you want to write it, which I'm going to call A. Oh, A's been used. Let's call that D. Okay. I'll work out D later. That one's going to involve actually working out a little bit of a sum rather than just necessarily doing that in my head, so I'll leave that like that for now. So this is f of x now fully factorised, but I've got 2 factors which have complex numbers in, and I wanted everything real. So what I'm going to do now is look at this bit and expand that, and that will give me a quadratic with real coefficients. So oh, the sign's gone wrong here. Now, when I expand this, I can see that 3 times negative 2i plus 3 times 2i are going to cancel out in the middle, so I'm going to write those down. And I always, rather than try and work this bit out for my head, I would write I squared first. So 2 times 2 plus positive 2 times negative 2 is negative 4, and then I times I is I squared. So I'll write that in first, you're less likely to make a mistake. And then we can use the fact that I squared is negative 1, so that becomes positive 4. Okay, so now I've got a quadratic factor, and I can use that to replace my 2 brackets, which use the complex numbers. And we worked out the third bracket had to be 3x, so that when you multiply all the x terms together, you get 3x to the power 4. And then now I can work out what d is. Now I can work out what d is by having a look at my function. I've got negative 104 on the end, and that's going to have to come from multiplying all the constants in the brackets together. So negative 4 times 13 times d must equal negative 104. And you can work out from that that d equals 2, and then we can write our final answer. And there it is, fully factorised. Okay, so the second bit of the equation. So the second bit of the equation is now to find the values of the constants a, b and c. So we want to know what f of x is now when expanded. So all you're going to do for this bit is just expand your function here. So remember, you do 2 brackets at a time. So for example, I could do the first 2. So I'm going to have x cubed minus 6x squared plus 30. And then I can multiply the other brackets together. If you fully expand it, you should get to 3x to the 4. That, and then have a look and make sure you answer the question. So the question said find the values of the constants a, b and c. So a is the coefficient of x cubed, b x squared, c x, etc. So let's make sure we answer the question. Okay. And there we go, we've made sure we've answered the question.